Hey guys, today we'll be looking at how to do direct titrations, specifically looking at, some of the common pitfalls or areas where students might make mistakes. Now, what I'm going to do, I'm just going to share my tab. We're looking at a specific question. We've got our example here. But before we look at our example, I want to dive into some of the common student pitfalls, and I also want to look at the common titration setup, just so you can have a visual understanding of what's going on before you try the questions. Now, the first common pitfall is that students don't know where to start. If you have a look at the example here, we're just seeing a bunch of different values and volumes, and we need a bit of structure in our head before we can get it down on the paper. Now, I've developed a sort of checklist, which is applicable to many sort of calculation questions. And I've given this generally for any calculation questions, what you do before you even start any calculations. So firstly, balanced chemical equation. It's really important. And I encourage this to write a balanced chemical equation, not only in questions where it explicitly says, but in many questions. I think this is good chemistry technique and what the markers want to see. Secondly, after you've balanced the equation, you've got to input any values from the question. And thirdly, identify what we're actually finding. So I would always, for me, this is always involve literally putting a question mark near the value or number I'm trying to find. Like I'd put it in this equation here, a question mark above it. So I'm always orientating myself towards that as the end goal. All right, now the second pitfall is that this is just a more general one. Students don't know how to communicate to the marker or what the marker wants to see in these questions. Now, I'll run you through it in my response, but as a paradigm shift, subtle shift, I want students need to understand that for HSC, it's not about getting the answer, but showing the marker you can get the answer. Now, I won't go too much on that one, but if you pause the video, maybe replay that a couple of times, you can kind of understand the subtle difference in that. It's all about communicating to the marker. That's all that the year 11 and 12 is about. All right. Now let's look at a common setup, which is going to be mirrored in example 1 we'll do. So in generally for direct titrations, you have one solution, which is of unknown concentration. It's probably what we're going to be wanting to find, right? In this case, it's HCl. And you have another solution, maybe if the first one was the acid, the other one would be the base, which is of accurately known concentration. They're saying this is an Na2 sodium carbonate standard. Now, I said it's a primary standard because it's a solution of accurately known concentration. Simple definition. And it's used, therefore, to find other concentrations, right? So that kind of, hopefully that makes that, it's kind of simple, that makes somewhat sense. Let's use all that thinking for this question here, the example. Students going to perform a titration experiment to determine the concentration of a solution of nitric acid. All right, we've got what we need. That's that third bit. Identify what we're finding. So it's going to be concentration of nitric acid. Now for each trial, 25 mils volume measurement of 0.05 mol per liter concentration of a sodium carbonate standard solution is used. So as I said, this is the primary standard. Why? Because we've got accurately known concentration. In your head, what are you thinking? Okay, we're going to use this to find the concentration of the other one. In this case, the concentration of a solution of nitric acid. All right. So we've got a table which has got volume measurements. Now, really importantly, we've got a rough titer. Now, the rough titer, experimentally, what's going on is that it's the first titer we're going to do. We don't know how the volume, roughly how much it's going to be. So what we're going to have to do is we're going to have to actually just quickly, roughly do it that first time and get a rough measurement, see where the ballpark is. And then after that, we can start to be more specific because we know where that threshold is for how much it's roughly going to take. The implication of that being is that we do not include this one in the average calculations. As I said, we discard or disclude the rough titer because we're trying to communicate to the marker, I'm literally going to write this, discarding or discluding rough titer. And then you perform your average calculation, which luckily this question is already done for us. A lot of the questions you will not have to do it yourself as part of the working. We've taken the average of these other 4 titers. Because they're within 0.05, they're concordant titers. So use these for average. Don't use the rough ones. All right, now we're going through our framework here, balanced equation. We've got it, it's just written here. Implication is it's 2 to 1, right? Key 2 to 1 ratio. 2 acid molecules react with 1 carbonate molecule to form what? salt in blue, water, and CO2 in yellow. Okay. Before we even start any of the calculations you see here, let's input the values into the equation. So I like to break it up like this. Let's put this key value. So what is this value here? Volume of nitric acid. Okay, we've got our volume here. So for V, well, V is always in liters. So it's going to be, what is this? This is for nitric acid. So we've got V, don't we? Okay, so we know we've got V. So see, I'm not even doing any calculations yet. I'm just going to walk you through it. What else have we got? For each trial, 25 mils of this of sodium carbonate. Okay, so we've got V for sodium carbonate. We've also got C for sodium carbonate. Have we got any other information? No. So this is all the information I've got, okay? So I'm going to work with what I've got to figure this out. So in order to kind of be exchanging or convert between any of these using the mole ratio, 2:1 in this case, you need to find the number of moles. We know that N is equal to C times V, C dot V. And as we've got both of these, we've got C and V, then we can just substitute it in to find how many moles, 0.00125 moles. Then, because we've got the reaction ratio or molar ratio, because it's 2:1, to find the number of moles of nitric acid, all you do is times it by 2. In order to times by 2, you have to be in moles first. So that's one of the key things we've had to convert to moles. Step 4, calculate the concentration of the unknown solution. So this is where we use C is what? N over V. As I said, we've got the volume for nitric acid. This was given in our table here. So because now we've got N, what is the question always asking? I had that in my mind the whole time. What I should have done, I should have put a question mark above what we're trying to find. I also see students write C equals, comma, question mark. So know that if we have V and now N, we can figure out C. So C is equal to N over V. So N over V, which is 0.0025, that's the N. And then we've got V, which is 0.02238. C is N over V, and then you get simplified to 2 significant figures. And that's the answer there. What students should do here is actually just quickly check. Most students go to the next question quickly. Just check that you've got what the question is asking here. Like have that last reflexive check, and then you should be all good to go. But yeah, hopefully the main thing you should take out of this is the framework I used. Did a balanced equation, and then I inputted values, and then I started my calculations. And that should provide a lot more guidance. So hopefully this video helped. All right, thanks guys.